In this video we'll be preparing crude acetamide as shown here, then using this to prepare acetonitrile, a useful solvent and reagent. First, measure out 57 ml of glacial acetic acid. It's called glacial because it's concentrated, and pure acetic freezes at a low temperature to form a solid which looks like ice. Now weigh out 61 grams of solid urea. Add the urea to a 500 ml flask. You don't need any stirring for this reaction. Now add the acetic acid to the flask. Some but not all of the solid will dissolve, but this is okay. Stir it around or swirl the flask so you've got a uniform mixture. Then set up the flask with heating and with a reflux condenser attached. Note that you'll need good ventilation for this reaction as fumes of ammonia will be produced. As you heat, you'll start to see the acetic acid reflux at around 120 degrees C. Refluxing becomes more vigorous and soon all the solid in the flask dissolves. Up to about 35 minutes into the reaction, some indicator paper at the top of the condenser only shows a slight acid reaction due to a small amount of acetic acid vapor escaping. This rapidly changes about 40 minutes in, and ammonia gas starts to be produced. You also begin to see a white solid starting to form in the condenser. This is ammonium carbonate or carbamate. Keep an eye on this, and watch it doesn't block the condenser. Leave this refluxing for a total of 3 hours from the point that ammonia starts to be produced. If it looks as though your condenser is at risk of blocking, there's a neat trick. At this point your circulating water will probably be getting quite warm, so top it up with boiling water. Around about 70 degrees C, the hot water will start to sublime the ammonium salts in the condenser, and you'll see them move up the condenser and disappear into the atmosphere. The acetic acid continues to reflux. Here we are after 3 hours of refluxing. A pale yellow liquid remains in the flask. We now switched the apparatus and set up for simple distillation, the idea being to drive off any remaining acetic acid from the mixture. To begin with, a small amount of ammonia was still produced and a little solid appeared in the condenser. We collected a small amount of liquid in the receiving flask. We distilled for a further 2 hours, and for the last hour we attached a vacuum pump to draw off any remaining ammonia gas and acetic acid. We kept the temperature below 140 degrees. Here's the result, an orange liquid remaining in the flask, which weighed 50 grams. We poured this into a container to allow it to cool. We recommend not doing this in the flask. And quite quickly it solidified with a lot of needle-like crystals forming in the mixture. Here's a sample of the crude product, 50 grams of acetamide with very little acetic acid aroma. As an interlude, we're now going to explore the dehydrating power of phosphorus pentoxide. There is a good reason for this, as you will find out later. Here's a small amount on a paper towel. The reaction with water gives off enormous heat, and you can see the paper char and then continue to burn. Let's add a spatula of sugar. Mix it around a little bit. Okay, it's showtime. Not as impressive as the sulfuric acid equivalent, but you can see the reaction with the sugar continuing even after initially kicked off with a drop of water. The important point is, be extremely careful about mixing this with organic chemicals or with wet material. The result can be enough heat to catch fire or ignite any vapors. We made this mistake in a different previous experiment using a solid which contained some solvent residue. So please do use a lot of caution if you go on to the next step of this reaction. In order to try to avoid an explosion risk, we wanted to purify our acetamide a little bit. First we dissolved what we could of the solid in hot methanol. There was some yellow solid remaining which didn't dissolve. So we filtered this off and collected the yellow filtrate. We then reduced this down in volume to around 50 ml on a hot plate, using lots of ventilation to avoid methanol fumes. We then chilled this down and added 100 ml of diethyl ether. After a few minutes of swirling the beaker, this crystallized. Suddenly, the heat of crystallization boiling off some of the ether in the process. We added a little more ether, then filtered off the solid, drying on the pump, and then placed in a desiccator for a few days in order to dry the solid. Because ether has such a low ignition temperature and has an explosive vapor, it is absolutely essential to get all of this off before proceeding. Before we did the reaction, we melted the acetamide again, in order to drive off any residual solvent and to make it easier to add to the reaction flask. We prepared a dry 250 ml flask, and working quickly, added 35 grams of phosphorus pentoxide, sealing the flask immediately after. Here's the 35 grams ready in the flask. Then we slowly and dropwise added 20 grams of the molten crude acetamide from the previous reaction. On addition, a lot of heat was produced and the mixture fizzed and smoked. This is partly impurities and partly the actual dehydration reaction taking place. We left the flask for 15 minutes before setting up for the next stage. We set up for simple distillation, using a heating mantle, and without a thermometer. Pretty quickly we got a solvent front creeping up the adapter, and soon distillation of a colorless, slightly oily liquid commenced. Distillation was fairly slow, and after about 45 minutes was complete. At this point we made up about 8 ml of the warm saturated sodium carbonate solution. We added this to the distillate, and a very small amount of bubbling occurred due to acetic acid present in the product. We put this into a separating funnel, and 2 clear layers were seen and allowed to completely separate. The upper layer is our product. We dried this using magnesium sulfate and then filtered out into a storage container. Here's our product, 9.1 grams of acetonitrile, which is a 65% yield based on the crude acetamide we used. We think this is pretty good overall. We're not sure if other dehydrating agents will work in this reaction, but they may be worth a try. Acetonitrile has an unusual aroma, which is difficult to describe. Not solventy, but not fruity either.